Hello, good afternoon to everybody. We will start the class now, just to be sure. And I'd just like to start with one announcement. Thank you, Paige. The disability resources, they contact me saying that some students required some accommodations, but I don't know exactly which accommodations they are. So whatever student needs specific accommodations. Zachary cannot hear me. I guess might be a problem with your computer, Zachary. So I don't know exactly what are the the accommodations, sorry, that I should do for students that went to the Disability Center, the Disability Resource Center. So you just email me the letter of accommodations, and then I can make whatever changes to the course that you might request, that you need. I will be really happy to do so. And so it's just I contacted the disability resources and they told me to tell to everybody. I mentioned to you that in our course website, all the lectures are already available there. So the lecture that we started in the last class is here, lecture chapter 1. That's a PDF file, and you simply just download it, save it in your computer, and you can make notes and whatever you want. I made some changes from Thursday to today just because of those graphs with information about the pandemic. I just want to have the most up-to-date information. And so it's available there. These first videos here, they give an idea, some introduction to demography, how demography can explain basic facts about the world. They're not required, but they're really fun. These first two here are really friendly videos. And if you have some time, just check them out. Hans Rosling, he worked more on public health, and he created this institute called Gapminder, which really shows all the statistical indicators and all this analysis, more quantitative analysis in a really friendly way. He died some years ago, but Gapminder still continues and they're still making those kind of videos. This is a short video from the New York Times about the growing population, a silly song about population. And then we will jump to chapter 10 after we finish with chapter 1. And this specific video here deals with population age structure, which is the topic of chapter 10. So that's why it's under that one. And the instructions about online quizzes and exams, I don't remember if I explained it to you, everything here, but you have all this information here, some tips about like the time that you're gonna have for the quizzes and everything. The add and drop date of courses changed from today until Friday. But as we had thought, I mean, we will have the first quiz this Thursday, okay? Because I had done the first quiz only on Thursday to be after the add drop date, but we will have a quiz this coming Thursday. So just be prepared for that. Canvas, the way that I organize it, it's really simple. You pretty much have this basic information, which is also in our website. And then you have announcements, assignments, discussions, and grades. These links here go to the same menus that are here on the top left. This is the view that you have. The announcements, this announcement here on the top is the same email that I sent it to you guys before the class started this semester, that same information. Assignments, that's where you're going to find the quizzes and exams that we're going to have throughout this semester. So we're going to have 3 exams, the final exam, and then 20 quizzes. The discussions is already open here. If you guys want to ask questions to me or to yourselves and want to start any debate that you might want, it's over here. I'll just be polite in this environment. But I also saw that some of you already are in the group me. So those that are not in group me, some students in your class already set up one group. And then you're going to be able to see your grades here as well. So that's the basic structure of Canvas. It's pretty much to have a record of our announcements, submit quizzes and exams, have a space for discussion if you want to, and check your grades. But most of the material is going to be here in the course website. And in the course website, after here, for example, this is an interview about internal migration in the US. It's only 5 minutes long. William Frey is one of the most well-known demographers analyzing migration in the US. And then after the last day, 28, and then the final exam after Thanksgiving. And here I have a series of websites with information for you. I put websites about the pandemic up on the top here. And then afterwards, US Census Bureau. If you want to check some, we will go through some of them in the class about sources of demographic data. I will give you some examples of how these websites, we can collect data there. But each one of these websites it's a learning process. I will give you an overview, but I left them here. If you have a specific interest and specific data, they're all available there. Demographic resources, mortality, fertility, migration, and resources about refugees, some household surveys that you can get some information. That Gapminder is that website founded by Hans Rosling, and some academic associations related to demography and sociology. Those who want to do literature review, the Web of Science is a really good resource, because here you know if you have a specific paper that you like a lot and you think it might be a reference for your area, you can see which other papers more recent cited it. So that's a really good website for you if you want to write a paper for a specific topic to do literature review. Or any link to the group me, please. If someone can share there, I don't have it. Some public opinion polls. The 538 is one of the most renowned statistical agencies that do analysis about election polls, and they have an interesting model. So this is just an interesting resource for a year of a major election as we have this year. So this is like many websites. If any of those links, you try to click on them, there is a problem, please just let me know, okay? And then I will fix it. And all the lectures are already available for download, as I mentioned before, but I might make some changes, and if I will let you know, such as today, I made changes to the lecture based on chapter 1, which is this one here. So we'll continue on. Thanks for sharing the group me link. The quiz will cover every time that we have a quiz. It will cover until the point that we cover up at the time of the quiz. So sometimes what I do, I know that I will talk about a specific topic, let's say early on the class on Thursday. So a question could be about that topic that I just talked earlier on Thursday. So whatever I talked to here in the class and we discuss in the class can appear in the quiz, even something that I talked on Thursday. Cool? Thanks for asking. So here, let me just, the pointer laser. So we talked about like what is demography, And one of the things that we discussed about John Grant, who is known as the father of demography, the founder of demography, is that he was really concerned with the quality of data. He was always thinking about the validity of data to do any demographic analysis. And so I showed here really quick in the last class this, this graph that just gives us an idea of how big the population of each one of these countries are compared to other countries in the world. So the blue countries here in Asia, orange Africa, Europe in green, America, North American in red, South American in purple, Oceania in pink, and it is two here, I don't know exactly. I took this, I don't know which one they refer to, but I took this, I downloaded this graph from this website, populationpyramid.net, which is also available in our course website. And I mentioned that demography is not only concerned with the size of the population. It's not just only concerned on whether the population is increasing or decreasing over time. It's also concerned with the distribution of this population and with the structure of this population. We want to know where people are located, the distribution of the population. We want to know if a specific population has more older people or younger people compared to other ones. And we also want to know some other socioeconomic and demographic characteristics of these people. And in demography studies, we are always concerned, not only with the size and growth of the population, but with the trends and levels of fertility, mortality, and migration. Fertility, mortality, and migration are the population, the demography components, or the demography processes. So these are the questions that I try to answer. How large is the population? How is the composition in terms of age, sex, race, marital status? How is the population distributed on space? And how population has changed over time? And again, what we have specific analysis only concerned with fertility, mortality, or migration, or we can also try to understand the interactions between all of them. And now here, I just decided to give you an overview of the pandemic that we are experiencing right now, and just to show that there is data out there, but we have to be careful when we analyze this data and what we hear usually on the news, because there's like a lot of story behind them, and it's usually really helpful to be careful when we read this information. This specific table, it's based on data from yesterday, from the worldometers.info/coronavirus. And in this case, I ordered the countries by the number of deaths. So this is sorted by the number of deaths: US, Brazil, Mexico, India, UK, Italy, France, Spain, and so on. And here you have the total number of cases, the total number of deaths, recovered people, active cases, serious, critical, and here are rates. And the rates, in this case here, I'm getting the total number of cases divided by the population per million, the number of deaths divided by the population, then multiplied by 1 million. Why do we multiply by 1 million in this case and in this case? Otherwise, these numbers would be too small. 181,000 divided by 331 million would be a really small number. So that's why, by convention, we multiply by these constants all over these places here. These are the total number of cases. That's the rate of cases based on the population, the denominator. This is the mortality rate. The mortality rate is the number of deaths divided by the population. And the number of deaths has been increasing pretty much every single year, every single day. The population also increases, but doesn't increase in the same pace as the total number of deaths related to COVID-19. But these are the rates. So the mortality rates in the US and Brazil are high, UK as well, Spain, Peru, and so on. These are the total number of tests, and these are the total number of tests divided by the population. So that's the rate of tests, right? So in a really simple table, bunch of different columns, we can already try to understand what's going on. And then I just got, to simplify, I just generated some graphs based on another website. All these websites, you can go there by yourself and you can get more updated information for today. This is for yesterday. I did this yesterday evening, try to be closer to today's class. And the next, and I just got here, I sorted by number of deaths, just to have an idea which countries have the most number of deaths. And then I went to another website and I just explored, I just generated some graphs with the countries going from 1 to the 8th position. So from the US until Spain. So this is another website, ourworldindata.org/coronavirus. Why I'm talking about this thing here? Because it's one of the major public health issues that we have been experiencing nowadays. That's why we are having classes like this. Someone asked, do you feel like the US ideas of freedom and autonomy have led to the US having more cases than other countries with similar populations? Yeah, it has been an issue that a lot of people have been debating, that the US, exactly because the government was not enforcing a lot any mandates on even mask use or anything, led it to the local governments. That is one of the main reasons that why we have so many cases and deaths going on in the US. And I'm gonna try to discuss a little bit about that, showing you the data. So, and this specific example, this pandemic, is related to mortality, which is one of the components in demography, right? So that's my idea, to bring it here to show that this is public health, this is demography as well. And here you see that the US had a huge increase in the number of deaths over time. The horizontal axis here is the days since confirmed cases first reached 30 per day. So it's not the same date for every country. They kind of overlap based on which day those countries reach 30 cases per day. And I'm starting it simple. I'm just putting here the number of cases. And I wrote here linear, because it's pretty much just getting the daily new confirmed cases of COVID-19 and showing in the graph. But there is a problem. This data varies a lot, would be a lot of noise here, a lot of oscillation through time. So what these places do, what they do, they get an average, rolling 7-day average, getting the average of 7 days and putting a specific day as the result. So the rates get a little bit more smoother. But you see that Brazil increased, decreased, and now it's kind of stable a little bit, but it's still in high levels. India is still increasing a lot. And in the US, what even yesterday, the New York Times had a long article about it, is showing that the US, the number of cases have been dropping a lot. But the issue is that if governments think, oh, okay, the number of cases are dropping, let's release all these requirements of wearing masks and social distancing. The problem is that if it goes back, the starting point here is really, really high to what it was some months ago. So what was some months ago right here. So we reach this point here from 0. And if we relax those requirements now, we are going to start going up again, but starting from a much higher level than what we were some months ago. Again, this is only for the 8 countries with more deaths, the ones that I listed in the previous slide. And you might have been hearing that, oh, the government should implement some policy to try to flatten the curve. What does it mean exactly? We better understand that by having the data not in linear format, like linear here. It really means that in this specific day here, India had 68,000 new cases of coronavirus. But if we get the log of the new cases, we pretty much kind of like shrink this information a little bit. And if the new cases are kind of stable over time, you're gonna see the flattening of the curve. So you said you had a flattening of the curve here in the US, it started to increase again, and now it's going down again. Brazil was increasing, it seems to be flattening now. So whenever you hear the term flattening the curve, probably they are talking about either the number of cases or the number of deaths, but in a log scale, right? So that's what you have to take into account when you are doing this kind of analysis. The log, because you pretty much get the information on these really high numbers, they get more close to each other and you start to see a more flat behavior. And you see in Italy, it started to drop some months ago, but then it started to increase again in more recent days, maybe exactly because they start to relax the requirements of wearing masks and social distance and everything. And then the cases started going up again. And what's the problem? They started already through a high level. They were also really low here, but now they're going up from a high level, and that's an issue. We talk now about cases. What about deaths, which is a major issue? Again, starting from the simple one, new deaths, linear, and here the countries are aligned by the days since the 5th day the new deaths was first reported for the same 8 countries here. So the US reached a really high number of deaths and decreased after some days and after a couple of months, and then it started to increase again, and now it's stable. So if I'm a politician and I'm more concerned with my election and I don't really care about the population, in this case, I would emphasize the number of cases because the number of cases are going down. But this is not the case of scientists who we are trying to be here, since we are in the university. In this case, what we are trying to do is analyze all this data together. And the data about deaths doesn't look good. It's still going up in the US and really high levels. There is some oscillation down and high and down and then stable again, but still at high levels and more number of cases than any other country in the world, even new cases of deaths. But the US is too big, the population is too big in the US. You have to consider the size of the population. That's why it's important to analyze deaths per million people, the death rates, the mortality rate caused by COVID-19. And just remember, in this case here, I just went to this website, Our World in Data, select those countries, and then you can select in the top in the menu if you want the number of cases, deaths, and also you can also select if you want per million or not. And then you say, okay, the US is much bigger than these other countries, so that's why it has more deaths than some of them. But still among these countries, the 8 countries with more overall number of deaths in the world, the US has the 3rd largest death rate caused by COVID-19. Yep.
I can't help but notice that I'm pretty sure just because it's no reliable data that China isn't on this list.
Yeah, the question was about maybe China is not on the list because they don't have reliable data. Also, this kind of questions has been raised about Russia because Russia has a lot of cases, but not too many deaths being reported. I agree, and it goes back and forth. That's why the US should compare itself more with countries that follow the same kind of political system, the same way that they deal with transparency in public health, right? So we could go there and debate about North Korea, China, Russia, but the problem is here. This is a fact. And if you compare to more advanced countries, Spain, France, Italy, and UK, they're all here. They have much lower mortality rates caused by COVID-19, right? and it's higher than India, but you could also argue that India might not have reliable data. But if you compare to UK, Italy, France, Spain, I did not put here Germany because Germany has much lower levels of deaths. They also have lower levels of death rates as well. But you could argue that, okay, the number of cases in the US are increasing a lot because the number of tests are increasing too much, because we are so good, we do so many tests that we have many more cases than anybody else. It's easy to say this kind of stuff, it's difficult to prove it. And how can we try to understand that? So one way to do it is to pretty much get the ratio. Divide the ratio, the number of tests divided by cases. See the terms that I use here. In this case here, new deaths per million people, this is the mortality rate. The number of people that live in that specific country who died. They were exposed to the risk of dying due to COVID-19, and they died. They were at risk, or they had the chance of going to the numerator of that formula, and they went. In this case here, the denominator is the population with a chance of experiencing the event that we are measuring in the numerator. That's the definition of a rate. A ratio, it's when you divide different groups, different numbers, that not necessarily one has a chance to go to the top. So if I get the number of tests and divide by the number of cases, these are different magnitudes, different sets of information. People who have a case, they are not exposed to the risk of getting a test. It doesn't make sense that way. In this case here, I just want to compare the magnitude, the pace in which tests and cases have been growing or declining over time. So for the argument, oh, the US has more cases because it has more tests. So let's say if we had 100 tests and one case, and let's say that the next day we have 200 tests, but we are controlling the situation, how many cases should we have if the pace remains the same?
One.
We should have 2 cases, right? 100 tests, 1 case. 200 tests, if everything is under control, I would have 2 cases in the bottom, right? So in this case, if that was true, the number of tests is increasing the same pace as the number of cases, we should have pretty much a more horizontal result of this ratio. But this is not what we are seeing here now. When the number of tests increases more than the number of cases, the ratio increases. So the ratio increasing is actually good, because we are increasing the number of tests in a faster way than the number of cases. So this thing here was good, and actually in more recent days has been good as well. And if the number of cases increase faster than the number of tests, then this ratio decreases because you have a bigger number here compared to this one here. So in this moment here, you're doing really bad. And I'm just showing the US here exactly because of the reliability of this data of tests and cases can be really difficult to compare among countries. And I try to focus on in the US. So you could make an argument, okay, so in these last few weeks, we are doing a little better because we have more tests, but proportionally the cases are not increased as much. But if you just go back a little bit to the number of daily deaths, we are still in high levels. Even when you divide by the size of the population, we are really up there in 3rd place among these 8 countries, right? And then going a little further in the US, looking for data in other places. The New York Times has some good maps so we can kind of see where we are in terms of counties. And this is our He also started by cases. That's the cases per population. So these are like, this is in proportion. You have the lighter colors here, 1 up to 1 in 200 cases. The little darker, the orange one, up to 1 to 100 and so on. And the ones in gray, no cases reported. So we are around here. And this virus will run its course no matter what we do through. Wasn't the initial reason for quarantine to flatten the curve. It was so that hospitals could manage the amount of people that were getting, so not so that people don't get the virus. You could do everything right and still catch the virus. Yeah. I can cross the street and the light for pedestrians is green and I might not die. Or is red and I might not die. There is a chance of not dying even if we do the wrong things. Always when you're talking about these measures to prevent a specific disease, in this case, mask, social distance and everything, it's a measure to decrease the probability. Whenever we are talking about probability, the probability is never equal to 0 and it's never equal to 1. So it's never 0%, it's never 100%. What us as scientists, demographers, public health professionals have to do is to think what are the policies that we should implement in order to make it less likely that people get the disease, overwhelm the hospitals, and then we do and then we decrease the chances of dying. We have to make sure we all do our part to protect the people who are at the most risk from the virus. And that's an important topic that Eric mentioned, because the fact that we are wearing the mask is not actually helping only us on not contracting the virus. Wearing the mask actually helps us if we have the disease, but we are asymptomatic, to spread it to other people. So the mask is not for us don't get the disease. It's actually to spread the disease if we are sick and we don't know. That's a major thing. So even when we see in campus here, people walking around outside, as soon as they get outside, they take off the mask, that exactly goes against this kind of thought that when you wear the mask, you are not actually caring only about yourself, you're caring about others, because maybe you are sick and you don't know. So you see a lot of variation here, and what you see is that in southern states, the rates of cases, the cases per population are actually really high, right? So this is really high, even compared to the Northeast where it started. I mean, of course, the rates there in New York City, they are really high, but also high in areas where we are living right now. And Brazos County is right here, right to the west of this red area here. So still a lot of variation and so on. This is the number of deaths overall. That's another way to represent data in demography, is to show the numbers with the diameter of the circles here in this case. And this is just to show that, yeah, the number of deaths are really concentrated in the Northeast and in bigger cities. Of course, this is driven by the fact that these cities have bigger population. So like we did for the case of countries, would be good to have this information of death rates, right? The deaths, but divided by the population in each one of the specific counties. So we can keep going and collecting more information. And then for the case of Texas, you could say, wow, that's really cool. Or at least we are getting better. The number of cases increased a lot. And then in more recent days, in more recent weeks, start to decline. And you have these peaks of cases that you measure here. And it's just the way that the agencies, they report the data vary. So you generate this noise. And exactly because this kind of noise that we see with observed data, that's important to have that 7-day average that wording data was also showing with us. So New York Times followed the same methodology. So here, number of cases is increasing. And then it was like, okay, number of cases is declining. kind of similar to what's happening to the US as a whole, right? The US, the number of cases increased and now started to decline. But then when we go to the number of deaths in Texas, we are still at the highest level that Texas ever reached during the pandemic, right? And the thing is that if you relax these measures now of masks and social distancing, you will start from here going up. You're not going to start from here anymore, right? So it's important to look at cases. The argument that cases are increasing because of number of tests, it's really not, if you look at the data, that's not so simple as is told, as is debated publicly. That's why you have to go after data. And what's still an issue is the number of deaths. It's still in Texas at the highest level since the beginning of the pandemic, right? And so all these discussions here to do this simple PowerPoint presentation, I had to go to 3, 4 different websites and get data and organize the thoughts and organize the ideas and have counter arguments and everything. So it's not easy. So that's why science is difficult. It takes a while to organize information, but it's important for us to be concerned that this topic is really serious and we have to have the most information as possible to understand the complexity of this issue. Any more questions?
Just a little, I'm just wanting more information about it. It says on that last slide, counting method change for deaths, and it has a little key at the bottom, but not quite sure what that means.
Yeah, these are deaths with data report and anomaly. And so if you go to this website here, the New York Times, and this is exactly for Texas. And if you click on this link here, it's going to explain it to you. And what it seems that happened is just the way that the death certificates were being counted. They were counted before now they are being counted more, not just of the confirmed cases, but some of the cases that they have some suspicion of the nature of the disease, they count as deaths reported as COVID-19.
Okay.
But
because it said it had changed, but it was also like the highest peak. So I didn't know if there was a different method that they used that just happened to reflect on the number of deaths that had changed.
It's the way that they are counting it. It's the way that the public agencies are reporting the deaths to the public.
Okay,
so
makes sense. Just a little simple question. Sorry.
No, yeah, that's a great question. I agree with you. And always when we get this data, it's important to go there in detail and see how the method was done. That's pretty much a methodology. It's just the way that they looked at their certificates changed a little bit in these more recent years than it was before. That's pretty much that. But I mean, your concern is right here. That's really valid. And I talked about it before. John Grant, the founder of Demography, to pay attention to quality of data, exhibited a healthy skepticism, questioned the validity and reliability of data. It's exactly what he just did. So what he just did is really important as well. What's the possibility of some of these cases being the flu? I really think that's not the case here. They are being much more systematic and trying to estimate the number of deaths really related to more respiratory diseases, and the quality of the test to know whether the person had COVID-19 or not at the time of the death, they are getting better in terms of quality. So to argue that actually newer tests are getting a worse quality and not capturing a possible incidence of the flu, it seems really not plausible because the tests are getting better in these last months. Well, thank you. That's a really good debate. You cannot see the slide here. I think people from home can. This is the academic building, the West. view. And this is my office right here, my office window. But we don't have office hours anymore in person, but we can have over Zoom. But that's where I'm usually located, this window over there. So going back into the textbook, the chapter 1, one of the main things that we discuss in demography is the demographic equation. The demographic equation is the one in which we try to understand how the size of the population changes based on variations of fertility, mortality, and migration. So the idea is that the population gets bigger or smaller pretty much based on these three components, in these three demographic components. There are two ways in which people enter a population: by being born or moving into that population. And there are two ways of leaving a population: either by dying or moving out of that population. Moving out, if we are talking about a country, moving in means people moving from other countries to a specific country. Moving out, people leaving to other countries. So it's pretty much fertility, migration, mortality, and migration again, right? So what we were talking here before about the pandemic, it's related to mortality. People can only change by way of a limited countable number of events. And the population can only change by a way of a limited countable number of events. So the size of the population is pretty much explained by variations in the level and in the levels and patterns of the three components. So this is the basic demographic equation. It's a simple equation. It's pretty much saying the population of a specific time t, a specific time at the beginning of the period, plus the number of births between that time and the beginning of the next year. Let's say that t is the year 2019, January 2019. The population in the US in January 2019. B here is going to be the number of births that happened in the US between January 2019 until December 31st, 2019. Number of deaths, the number of deaths that happened exactly in that same year, January 1st, 2019 until December 31st, 2019. Number of people that entered the US from other countries from January to December 2019. And the number of people who left the country in that same period. That will give us the population in January 1st, 2020. So the basic demographic equation, it pretty much measures how the population is going to be in the next time period based on information of the previous time. And this time period here, I did as 1 year. So if I want to say the population in 2000, and I want to understand what's going to be the population in 2010, 10 years later, so I still get the population in 2000 as the baseline, but then the number of births goes from 2000 to 2010. The number of deaths from 2000 to 2010. Okay, so this time interval here can be of 1 year, 2 years, 5 years, 10 years, depending on your interest and the data availability. So PT plus 1 is the population at the end of the period. PT is the population at the beginning of the period, number of births in between in that time interval, number of deaths, immigrants, and emigrants. And just an interesting terminology here. When we are talking about information about countries, I just mentioned here the population in the US in 2020 based on data from 2019. These ones here are immigrants or emigrants. Immigrants or emigrants because they are international migrants. If I want to do the same exercise for Texas, then the E, the I, and the E, they refer not only to people migrating to Texas from other countries and leaving Texas to other countries, but also people moving to Texas from other states in the US. So when we have internal migration, the correct terms are in migrants and out migrants. People moving to a specific area within that same country, we are talking about in migration. People moving from one state or one county to other areas in that same country, out migrants, okay? So if we are talking about countries as a whole, we consider only immigrants and immigrants. If we are talking about subnational level, then we have to take into account internal migrants as well. This is a really basic equation, and it already gives us some ideas of how the population is behaving, is trending over time. If the number of births is higher than the number of deaths in a specific time period, we have what is called a natural increase. If number of births is smaller than the number of deaths, we have a natural decrease. Or we could also say a negative natural increase, but it's kind of like a double negative here. It's easier to think like natural increase and natural decrease. See that in this term here, natural increase and natural decrease, we are not taking into account migration. Whenever we are talking about natural increase, natural decrease, natural increase rate, or natural decrease rate, we are taking into account only fertility and mortality in a specific time interval, okay? So that's an important thing. For migration, we also can analyze the specific components of this equation related to immigration and emigration. So when we subtract the number of immigrants to a specific country minus the number of immigrants to that specific country, you have pretty much the net international migration, which is immigration minus emigration. But let's say that I'm trying to understand the population in Texas itself, just of that state. And in that case, I have to think about all people that enter Texas, not only from other countries, but even from within the US, and those who left Texas, not only to other countries, but also to other areas within the US. So I'm doing an analysis of net internal migration. So that's in migration minus out migration. When the number of immigrants is smaller than the number of immigrants, we have a negative net international migration. These are usually descending countries. Sending countries, usually they have more people leaving, getting out of those places. So it's smaller immigration than immigration. If I'm talking about internal migration, the number of immigrants in migrants is smaller than the number of out migrants. We have a negative net internal migration. So for example, states in Midwest in the US, they usually have fewer people in migrating to those states compared to those getting out of those states. So they have a negative net internal migration. The US has a positive net international migration. It's considered a receiving country because it has more immigrants than immigrants. The state of Texas is considered having a positive net internal migration because it receives more in-migrants from other areas in the US than actually sends people to other areas within the US, okay? So the terms of immigration, emigration, and in-migration and out-migration, they can also, we can do the simple comparisons here to understand how migration might be contributing to that population decreasing in size or increasing in size. So I could ask you, a country that has kind of stable number of births and deaths over time, if they have a positive net international migration, is that population of that country increasing or decreasing? Increasing, because they have more immigrants and immigrants. Oh, what about fertility and mortality? I just said it's stable over time in my example, okay? So these basic questions you have to understand in order to see how fertility, mortality, immigration, and immigration affect the population size. Another thing, this is some basic information that I took even out of the chapter just to complement it, because it's important for whenever we are doing data analysis. And in demography, it's really, really important that whenever we are doing some data analysis, we are trying to understand the characteristics of a specific population, characteristics that can change values from case to case. So for example, if I'm trying to say what's the proportion of men and women in a specific population, what's the proportion of people with 10, 15, 20 years of age, what's the proportion of people below the poverty line, what's the proportion of people that have a specific political party affiliation. These are all characteristics of the individuals. So I have to interview each one of these individuals. And those characteristics of the individuals are my variables. Each one of the individual that I collect information to ask about gender, age, income, and political party affiliation in my example, they become an observation in my database, right? So if, I don't know if I can do, so for example, I collect the information on, this is easier to do like this. Just to explain what exactly a database is, it's pretty much this. Things like opening. Can you guys at home see the Excel spreadsheet? Thanks. Let me just, let's say that I talk to, I will get the name of the person, the gender, and then the age. And then I interviewed Maria. It's female. She is 20 years old. And then I talked to João, which is a Brazilian name, male, and he is 22 years old. This is a database. Where are the variables? The variables are the columns, and the observations, the cases, are the rows. Let's say that if I interviewed one more person, let's say Laura, female, she is 24 years old. This is the micro data. That's what's called the micro data. I have one row for each individual here. And the variables are my columns. The rows are my observations. And the unit of analysis here is the individual. Each individual is one row. The unit of analysis could be country. Oh, yeah, we saw a database already in class today. This is a database. This is a database. In this case here, each one of the columns is a characteristic of the country. The country is the observation, is the case, is the unit of analysis. So this is a database. Variables, characteristics in the columns, cases, observations in the rows. In this case, using this information from this fictitious database, I can do some aggregate level analysis. For micro data, I can do aggregate level analysis. What's the percentage of women in this population? .66%, right? So I just count 2 women here, divide by 3. 2/3 of my population are composed by women. What's the average age of women in this population? 22. 20 plus 24 divided by 2, 22. So with disaggregated level analysis, I can do aggregated level analysis, right? So this is a database. And actually, we had seen already a database earlier today with this information from the coronavirus pandemic, that each one of the columns here are one variable related to the pandemic, and each one of the rows is one observation. So that's what I'm explaining in those slides. And that's important to understand because that's how most of the data that we analyze are organized. So variables are a characteristic whose value varies from case to case and is empirically quantifiable. So we can actually analyze, collect them. We can quantify man or woman, age, income, political party. I'm from political party A, B, C, or D, and so on. And then we can be a little bit more detailed. Is this characteristic, I'm going to analyze it as a dependent variable or independent variable? The dependent variable is that variable that depends on other variables. The independent variable is pretty much the causes of variations in another variable. So for example, economists use income a lot as a major dependent variable in their analysis. What are the possible independent variables that produces variation in income? In my example, income is a dependent variable. Age, usually older people have higher earnings, and after a while, their earnings decline as they retire. Occupation, depending on the occupation of people, they have higher earnings. Marital status, usually married people have higher earnings. Sex, usually men have higher earnings, even controlling for other characteristics of even getting men and women with the same level of education, occupation, and so on. Still, we have a gender gap in income in the US. Race, ethnicity, a lot of variation as well. So all these other variables that I mentioned here are independent variables. They are associated with changes in my dependent variable that in my example is income. Okay? Let's talk about demography. Fertility. Fertility of women, how many children a woman have. Depends on woman's age. Depends on woman's education. Women who are higher educated have fewer children. Depends on race, ethnicity as well. The fertility rates are higher among Hispanic women than, for example, non-Hispanic white women in the US. Mortality. Those people, even contracting COVID-19, the ones that are more likely to die are the ones who are older. Age is an independent variable to explain mortality due to COVID-19. Right? Migration. People in labor ages between 25, 35 years of age are more likely to migrate, looking for jobs. Age is an important independent variable to explain migration, a dependent variable in this other example, right? Oh, I just saw here that you gave examples. Yeah, age, education level. These actually are independent variables for all these examples that I gave for income, fertility, mortality, and migration. Cool. Also, higher educated people, they tend to migrate more farther distance than lower educated people. So there are several studies showing that. So these terms, variable, observation, dependent variable, independent variable, these are things that you're going to hear a lot. Whenever you're doing social science studies, doesn't matter if it's economics, sociology, urban planning, anthropology, it doesn't matter the major. In social science as a whole, these are major concepts that's important for us to know. Right. And depending on the science where you are, you're going to see some other terms. So usually, generically, people use the terms dependent variable and independent variable. But you might also hear the terms explained variable, explanatory, response, control variable, more in experimental science, predicted variable, predictor, outcome, covariate, regress and regressor. In demography and in sociology, what we do a lot, we have, for example, a main dependent variable that I try to analyze. Let's say migration, and we have a series of different factors that influence migration. But I already know that these other factors influence migration based on previous studies. I want to control my analysis by them, but I'm including a new independent variable that's the most important for me. So in that case, I can call that specific variable the independent variable, and the other ones the covariates. Right? Oh, I have this analysis looking at the association between education level and migration with a bunch of other covariates. So whenever the person says that, oh, I have many other covariates, actually the covariates are the same thing, they're also independent variables, but they are not the focus of the analysis, okay? Observations, as I said, in the example, the table from the coronavirus pandemic are the countries. In the example of the Maria, João, and Laura website are the individuals in the cases. We decide how variables will be measured and how cases will be selected and tested. So do we want a sample that will be representative to our population? So we decide all those steps in our analysis. And whenever we measure social reality, we collect information in a numerical way. So in this case here, when you collect information like this, for gender, female or male, you usually transform it in numerical way. So you create a new variable, for example, called female. It's going to be 1 when it's a woman and 0 man. 1 woman. Or you could have created a variable called male, 0, 1, 0. So that's what you're saying. Even data that's more categorical like this, you can also transform it into a numerical format. So information can be organized in databases, variables in columns, observations in rows. This is another example. This is Introductory Econometrics by Woodridge. Each one of these rows here is the information of one worker. So this worker number 1, the salary was $3.10 per hour, had 11 years of schooling, 2 years of experience in the labor market, was a woman, and was not married. Marital status here is simplified. 1 married, 0 not married. And we have a database with 526 rows. So the database can be really long with a lot of cases. It can also be really wide, a lot of variables. Any questions? This is important. I could even have flipped this because we finished here with example of a database, and I could have come with the coronavirus afterwards. When we are doing studies about demography, we can have different focuses. And then the demographic models can be pretty much subdivided in these 3 groups: formal demography, population studies 1, and population studies 2. In order to understand it, it's really simple. You can just organize these little diagrams here. In formal demography, both the independent variable and the dependent variable are demographic variables. So the explanatory variable and the explained variable, they are both demographic variables. And examples of those, if I want to understand if the age composition of a specific country affects birth rate. For example, if I have more women in reproductive ages between 15 and 49 years of age in a specific country compared to the other, then the birth rates will tend to be higher than in other countries. At the same time, there is a little bit of a reverse causality here. The economists call it endogeneity. What is endogeneity? A specific variable affects another variable, and this other variable affects the first one. Because, okay, let's say that we have a higher proportion of women in a specific country between the ages of 20 and 35. Those are the ages that we have a high fertility rates, for example, 20 to 35. So, if proportion we have more women in those ages in a specific country, they will have higher birth rates compared to other countries. But as they have children, then you're going to start to have a lot of children below the age of 5, below the age of 15. So high birth rates influences the age composition. If a specific country has high birth rates, that will cause that population to be younger in a few years, in a couple of years, in a few decades. The sex composition of immigrants to a specific city affects the sex ratio of the total population of that city. Remember, ratio. What is sex ratio again? I mentioned in the previous class. If you get the overall number of men in a specific population, a specific year, divide by the number of women, that's the sex ratio of a specific population. And if you're talking about a city, of a specific city. Sex ratio at birth is the number of boys being born in a specific place, in a specific year, divided by the number of girls being born. Sex ratio as a whole, number of men divided by the number of women. And if a specific city is receiving many more men than women, that composition of immigrants to that city will affect the sex ratio of the total population. See that in this example here, both the independent and the dependent variables, they are demographic variables. They are related to fertility, age composition, sex ratio, migrant characteristics, and so on. If I'm doing a study in which my independent variable is non-demographic and the dependent variable is demographic, that's social demography. And that's what usually the topic of this course here is social demography, because we are trying to understand the association of demographic variables with non-demographic variables. And the authors, they just subdivide this a little bit in two groups. We can have population studies in which the independent variable is non-demographic and the dependent variable is demographic. For example, the social class of an individual affects the death rate of that specific group. And that's more a sociological variable. Attitude about motherhood affects how many children women want to have. This is a social psychology variable, influence a demographic variable. Annual rainfall, geographical, influence population density. Economic opportunity, economic variable, influences migration. A country that has a lot of economic opportunity will attract a lot of immigrants, right? So this is social demography. The other way around is also social demography, an independent variable explaining a dependent variable. An independent variable that is demographic explaining a non-demographic dependent variable. So in this case, the age composition of a specific population affects the voting behavior. Maybe younger people tend to be more liberal. So demography explaining politics. Migration explains social change. More people move into a specific area that can create some tensions or can create some changes in that country. So that's demography influences sociology. Birth rate, if we have a high birth rate in a specific country, more children being born, then we will need more services, public services for children and infants. So that's demography explaining public health. In my dissertation, I pretty much looked at how people getting older and better educated changed the composition of the population. Getting older, why? Because of the decline in fertility and decline in mortality. Fewer children, people live longer, older people. And people are getting more educated in Latin American countries, not as much on the overall levels as the US, but they are getting better educated. How that affects the competition of those people in the labor market and might affect their earnings. So my dissertation is social demography. It's an independent variable influenced by declining fertility, declining mortality, and improvements in education, how that increase or how that affects earnings in a population. Earnings in this case is a economic variable, non-demographic, right? Questions? An important topic, an important concept in demography is cohorts. Cohorts are a group of people who have experienced a common event during a given time interval. Birth cohorts are sometimes referred as generations. Why do we study birth cohorts? If you understand what distinctive opportunities and problems you have faced as a group, you can find common ground with others in your generation and in other generations. You might have heard here, for example, which class most of you are. 2021, 2022, something like that. So that's your cohort. The cohort here at A&M is measured by the year that you expect to graduate. It's a way of the university to push us all to finish in 4 years, which is great. And some other places could classify a cohort based on the year that you entered the university. But overall, the idea here is to classify people by cohorts, in the example that I just gave, by the year that you are in your program, to analyze them as a group. But cohorts in demography, most of the time we analyze, we classify people based on year that they were born, or around the decade that they were born. The baby boom cohort. The baby boom cohort is a term that we always hear. Those people that were born right after World War II, and we're going to talk about them here. Right? And this group of people live through childhood, adulthood, and when they're older, together living the same socioeconomic characteristics of that specific country. And that's why it's important to understand these people as a group. So some examples of cohorts: people born during the same period who experience similar social circumstances through their lives. The lucky few were those born around 1929 through 1945. Why fertility rates were low during that time period? Because of the economic depression, 1930s, fertility declined, and then at the end, fewer babies were born, and then when they went into the labor market, there were fewer people competing for jobs. The baby boomers was the opposite. After World War II, new life, new society, everybody changing, really optimistic about the future, better economic growth, more children. And then these people that were born between 1946 and 1964, they entered the labor market around the end of the 60s and beginning of the 70s. So they are a bigger group. They start to compete for jobs. Their earnings decrease. There are a series of studies talking about them. And right now, this generation is the one getting retired. And then you have a lot of people proportionally retiring, putting pressure on Social Security. So that's demography affecting the labor market and affecting the Social Security system. The baby bust cohort, also known as the Generation X from 1960s to early 1980s. These other classifications here, millennials, Generation Y, and Generation Z, there is no consensus about it. And also because the idea of cohort is that This is not a set interval. It just gives us an idea of group of people that were born and experienced the same structure in that specific society, the same opportunities, the same socioeconomic opportunities. So it's a way to simplify the issue. But if you want to go deeper, you're going to have to cut them more in subgroups, not in these groups that are like have an interval of around 20 years for each one of them. So I will keep talking about this in the next class, and then we will go to chapter 10 related to age composition. So thank you very much. I hope the recording worked today, and I will post the recording on YouTube. Thank you very much, and I see you guys on Thursday.